Learning target 3. I can find the percent of a number. Another learning target that we've done on review sheets several times throughout the year already. So again, this should really be review. So that's kind of why we put them on the review sheets that far ahead. So go ahead and go to page 4. Now I know that we skipped this on the last video. It's okay. Don't worry. It's not any big deal. We did enough practice with that, I think. So I can find the percent of a number. Okay? I can find the percent of a number. Okay, this is a very, very important thing, I think. This is one of the more important things that we actually do. Okay? Finding the percent. I mean, percentages are everywhere in our life. I mean, this isn't just learn it in math and forget it. I mean, your parents, everybody uses percents in real life. So, this is one of those easy times where you guys might ask me, well, when will I ever use this? Well, percents are all over the place. Okay, you guys have your biggest experience with them is grades. Okay, just to recap, percent means per 100, right? Okay, steps to finding the percent of a number. Okay, the word of in math means, I've said this about 100 times this year already, it means multiply. Please write that. You got to know that the word of, if I ever said find 12% of something, it just means multiply. But there's a trick to it. There's something you've got to do. So let's look at number 1 here. Okay? Well, actually, let's look at our steps, because I put these steps on here, and I don't like just teaching you steps. By the way, does anybody remember what this is called? Anytime I'm giving you steps. Okay? Remember that from chapter 3. Okay? Algorithm. An algorithm is a set of steps. Okay? There's an algorithms for a lot of things. Now, I don't really want you guys to just memorize this algorithm. I really don't. I don't want this to be turned into, okay, what was step 1? What was step 2? What was step 3? I want you guys to really understand it. Okay? Okay. To find 60% of a number, okay? Well, first of all, it says turn the percent into a decimal. So you guys already know that turning the percent into a decimal, and I'm going to rewrite this over here just for a second, just so I have a little bit more room. Okay? Okay? Well, actually, you know what? Before I actually go any further with this, I want to see something. Let's think. I want everybody to think. Okay? I want you to try to think. What is 60% of 5? Okay? Think of it this way. If I had 5 whole pizzas, okay, and I had 60% of those, how many pizzas would I have? Maybe some of you are getting the answer. If I'm not asking for the answer, I'm just asking for an estimation. I'm just asking for a guess, somewhere in the ballpark. Okay? And my ballpark would be, okay, 60% is really close to 50%, right? It's pretty close to it. So if I had 50% of these, I have 2.5 pizzas. That wasn't a very good line, was it? Sorry about that. I have 2.5 pizzas. That's pretty close. So that's a good guess. Or you could say, well, okay, 60 is still more than 50, so I have probably about 3 pizzas. I want to start doing that every time. I want to make a prediction so that you guys can actually think about your answers when you get them. Because a lot of times, like when I'm grading your guys' tests, there's answers on there that just make no sense at all. And I say, they just made a silly error. But why didn't they look at their answer and say, man, that answer doesn't even make sense with the problem? Like if your guess here was 7 pizzas, if you thought, oh yeah, I think it's 7 pizzas, that's the kind of answers that I would get on a test, like last year and stuff. Well, if you only have 60% of your 5 pizzas, you certainly can't have more than 5 pizzas, right? 100% of 5 is 5. Okay, so it's got to be somewhere less than 5. Okay, so start thinking about this every time. So step 1 says you need to turn the percentage into a decimal. Okay, well that's easy. I know that I just moved the decimal to the left 2 places. Now remember, there's no decimal here. Okay, so I got to move it 1, 2. Guess I shouldn't say turn it to a decimal. I should say turn it to a regular number per 1, right? So that's going to be 0.6. Okay, then it says turn the word of into a multiplication sign. Okay. And by the way, you could leave this as 0.60, by the way, for those of you may be wondering. 0.60 is the same thing as 6.6. Remember, 0.6 would mean 6 dimes, which is technically 60 cents. Okay? 0.60 times 5. All right, well, let's do it. Here we go. 0.60 times 5. Oh, the answer is 3. So the answer to the question here. How many pizzas would I have if I had 60% of my 5 that I originally bought is 3? Okay, let's go on to number 7. 5% of 20. Now, everybody stop. Take about 10 seconds, and I want you just to make a prediction. Just make a prediction of what you think the answer might be. Okay, my ballpark guess, I'm just going to go out on a limb, and I'm going to say, okay, I know that 50% of 20 would be 10. Okay, this is just 5%. I'm going to say 1 or 2. I'm going to say the answer is close to 1 or 2. I don't know. But it's going to be a really small number. It's going to be somewhere less than 5. I know that. Somewhere less than 3 even. Okay, so let's do it. Let's turn this into a regular number. So I move the decimal 2 places to the left. 1, 2. So that's 0.05 of becomes multiply times 20. Now we get out our calculator. Okay, and that's going to be 0.05 times 20. Oh, the answer is 1. Okay, so hopefully you made a guess around there somewhere. Let's do this one. 10% of 10. Okay, make a guess. Okay, hopefully your guess was somewhere really close to 1. Again, because if I thought, think about it, 50% of 10, I mean, that's easy. What's half of 10? 50% is just half. What's half of 10? Well, it's 5. So I know this is going to be a really small number. It's going to be somewhere around 1. Okay, so let's just follow the algorithm. This says turn your percent into a regular number, so that's going to be 0.10. Move the decimal 2 to the left. Times 10. Okay, get out our calculator. 0.1 times 10 equals 1. So 10%. If I had 10% left of my 10 pizzas, I'd have 1 left. Okay. Then number 9. Okay. I use a different color so we can tell. This is going to become 0.43 of becomes. Oh, real quick, actually, before we do this, make a prediction. What do you think the answer is here? 43% of 100. Okay. Let's put it in real life real quick, and let's say that I have a pizza or a cake that is cut into 100 pieces. If I have 43% of them left, doesn't that mean I just have 43 pizzas? Or 43 pieces of cake? Okay, but you can do this if you have to. You shouldn't need to in this case, because if you have 43% of 100, if you know you're asking for a percentage of 100, then that's how many you have of it. The answer is 43. I know that there are 2 zeros. I move the decimal 2 to the right. The answer is 43. Okay? Go ahead and go to the next page. Real world problems. A fruit display. Let me zoom in a little bit. A fruit display of 50 apples has 43 green ones. What is the percent of green? Okay, now let's just think about this for a second. This is where all these percentages all come back to fractions, all come back to ratios. That's all it is. You can see that they're giving you 43 out of 50. Okay. Now there's a couple different ways you could do this. Okay. I'm going to show you both ways. Okay, the first way, what I'm trying to get you guys to see is this bottom amount. It always represents a whole amount. Okay, 50 apples. Remember how I told you earlier in the year there was a part-to-part ratio, there's part to whole, but there is not a whole to part. Not a whole to part. There's no such thing as a whole to part. So if there are 50 apples, 43 are green, then the ratio is 43 out of 50. Okay? Now, I'm going to do it the way they did it first. Because this whole amount is 50, and I know that percents are always per 100, I personally can just look at this and I can say, oh, if I got a 43 green apples out of 50 apples, I know that I'm just doubling to figure out per 100 meaning percent, I'm just multiplying by 2. Multiplying by 2. So I get 86%. Everybody see how I did that? Sometimes you can do it that way. That's an easy way to do it sometimes, is just to look at your whatever your whole amount is and see if it can become 100. Now, the other way you can do this is, sure, you can just do what we just did on the previous page. 43%. We can divide it. Okay, or what we did, not in the previous page, but on Learning Target 2. We can just come up here and go, okay, 43, I'm going to divide it by 50. I'm going to get 0.86. That's my regular number. Then I'm going to turn that to a percentage, 86%. It doesn't matter how you do it. There are so many ways you could do it. Okay? There are so many ways. Okay? What you did here is you just turned it into a regular number. See what I did there? I divided by 50. I divided by 50. I multiplied by 100. I multiplied by 100. That goes right back to what we did in the first two learning targets, guys. I hope you're making that connection. That is this. It's the same thing. It is the exact same thing. Okay? Let's go down. Of the 2,000 people at the concert, 240 are teachers. The rest are students. What percent of the people at the concert are students? Well, again, there's a couple different ways you could do it. We could figure out, okay, if there are 240 teachers and there are 2,000 total people, I'm just going to put P for people, put teachers. Okay, I could do this two different ways. I'll just do it this way first. The first way I'm going to do it is I'm just going to divide 240 divided by 2,000. 240 divided by 2,000. I'm going to get 0.12. Okay, which I know turns into 12%. Now, that is not the answer. Why is that not the answer? This is why every test, when Mrs. Godfrey harps on you guys about how important reading is, it is the most important thing you do in school. Because you're not going to see percentages on an IE test. You're not going to see percentages on Savely's tests or a social studies test, probably. You could see it in Glassburn's a little bit. Sometimes math and science overlap a little bit. But the one thing that's going to be on every test you ever take is reading. That's why those of you that hate reading, it's holding you back a little bit. Read what it says. It says 240 are teachers out of the 2,000. The rest of the people there are students. Okay? What percent of the people at the concert are students? This is not the percent of the people are students. This is the percent of teachers. Teachers at the concert. Well, if 12% of them are teachers, then the remaining, because it says right here the rest are students, the remaining people are the students. So we know that 100% is the whole amount. I'm just going to do 100% minus 12%, and I'm going to get 88%. Okay? That's 80% are students. Okay? We come at this from a little different angle now. We do it one other way. Okay? Let's just do it from the beginning. Let's say, okay, there are 2,000 people. Let's skip this step down here. Let's just skip that. Check out what I do. If there are 2,000 people at the concert, and 240 are teachers, and the rest are students, well, can't I just subtract 2,000, and I can just subtract out my teachers? That tells me, let me do that again, make sure I typed it in right. 2,000 minus my 240 teachers, and I get 1,760 students. It's easy enough. If there are 2,000 total people there, I subtract out my teachers, the rest are students. That's easy. So now let's do 1,760 divided by 2,000. It's 0.88. What is 0.88 as a percentage? Well, it's 88%. Isn't that what we said the answer was? Okay. So there's different ways you can go about this stuff, guys. That's what I'm trying to show you is there's multiple ways to get to where you need. I'd like you guys to try number 1 and 2 down here, please. Okay? All right. Out of 25 chairs, 14 of them are brown. What percent of the chairs are brown? Okay? Well, let's think about this for a second. I'm going to show you about 3 different methods you could use here. The first method is the one I just showed you. I know there are 25 chairs. Remember, there's no such thing as a whole to part ratio, only part to whole. Okay? 14 of them are brown. Okay, well, you could just go ahead and divide them. 14 divided by 25, that's 0.56, which I know is 56%. Method 1, maybe use that method. That's great if you did. Nice job. Let's use a different method. If I know there are 14 brown chairs out of 25 total chairs, well, I noticed right away, and maybe you guys noticed this too, is I noticed, hey, wait a minute, 25 can become 100, and I know that all percents are per 100. Okay? I know that 25 is a factor of 100, so I know that I can just multiply by 4 to get to that. And that's going to give me my percentage. That's a lot easier than doing all this other stuff. Okay? Times 4, and I get 56 out of 100. Therefore, my answer is 56%. Okay? Okay? The final way that I could do it, well, you know what? Let's just stop on that one. I'm not going to show you another way. Okay? Let's check out this one. Out of the 400 zoo animals, 32 of them are monkeys. What percent of them were monkeys? Oh, okay. So I know there are 32 monkeys out of 400 animals. Okay? I could just go ahead and divide them. Maybe that's how most of you are doing it. I don't know. Okay, that's going to give me 0.08, which I know, move the decimal to the right 2 places, is 8%. Okay? Could do it that way. Or you could do it this way. You could say, okay, 32 out of 400. Notice I'm still putting labels, guys. That doesn't stop all of a sudden. And I know that I need to get it to 100. Okay? And this goes back to this one up here, too. Let's say you don't know what you're doing to go from 4 to 100. Maybe you don't. That's okay. It's no big deal if you don't. It's not the end of the world. Okay? Let's say you're not sure what you're dividing by here. What could you do? Remember, we learned it last chapter. Cross multiply, divide. You can still do that, guys. You're just saying, okay, if the ratio of monkeys to total animals is 32 to 400, then what would the ratio be of monkeys if there were only 100 total animals? Because percents are per 100. Okay? It'd give you the same answer. You're going to be getting 8. If you did know that 400 divided by 4 was 100, which it is, then you do divide by 4 here. You get the same answer. Okay? Let's go to the next page. Oh, I guess B should be on the, I don't know, maybe B on your copy is on the previous page. What percent of the animals were not monkeys? Well, if 8% were monkeys, how many, what's left? You just take your whole percent, 100, you subtract out your 8, you got 92%. 92% of the animals were not monkeys. Not monkeys. Okay? Okay, out of 500 total flowers, 65 of them are roses. Okay, so I have 65 roses. I have 500 flowers. Sounds good enough. Okay, what percent of the flowers are roses? Well, we'll just do it this way this time. You could just divide 65 divided by 500, get a decimal or a regular number, and then multiply by 100 to get a percentage. Or you could look at this and say, oh, I know that I'm dividing by 5 here. I know that I'm dividing by 5 here. And I'm going to get 13%. Okay? It's all equivalent ratios. It's the same thing we've been doing. It's just now we're dealing exclusively with that, per 100. That's the only difference between this chapter and last, is we are dealing with the number 100 more often. Of the 200 packages of bagels sold, 15 of them are sesame seed bagels. What percent of the bagel packages sold are sesame seed? Okay, so 15 SS, sesame seed, out of 200 total packages. Okay, let's do it the other way this time. Instead of, I'll do it both ways actually. Okay, if I know that I can just divide 15 divided by 200, 0.075, which becomes 7.5%. Okay? Let's do it the other way now. 15 sesame seeds out of 200 total packages. I know that 200 can become 100. If I cut my packages in half, can I just cut my sesame seed packages or sesame seed bagels in half? 7.5. Same answer, guys. Hope you're seeing it. It's the same thing over and over and over. In a survey of music performances, 81 out of 450 students said they preferred country music. What percent of the students preferred country music? So we got 81 that liked country out of 450 T. Remember, part to whole. Whole always has to go on the bottom. Now here, again, there's a couple different ways you could do it. You could just go ahead and do this. 100 total. Now, you might be saying, well, wait a minute. I don't know what I'm dividing by to go from 450 to get to 100. Well, I don't either. Okay? But remember, you can always just cross multiply and divide. You're just changing your whole amount. You're saying that I want to always make my whole 100. I always want to figure out 100 total. So if we did it that way, 100 times 81 divided by 450, going to give me 18. 18 liked country out of 100, which means that 18% preferred country. Okay, let's do it the other way. 81 out of 450. We divide that, 81 divided by 450. We're going to get 0.18, which becomes 18%. Okay? Okay? There are 750 spectators in the stadium. 420 are women, and the rest are men. 420 women, the rest of them are men. So 750 total. Okay, let's figure that out. What percent of them are women? Okay, so I do 420 divided by 750. Okay, that's 0.56, which equals 56%. So that's the percent of them that are women. So this is 56%. Okay, well, if 56% of them are women, then what's the remaining percent? 100 minus 56. It's going to give us 44% of them are men. Okay? Okay, the music, you know what? Let's just end on that one. Okay? See you guys.